Okay, so we're going to finish up 4-4 today. We started this on Friday. We talked about how to find the list of all possible rational roots.
We're still talking about 4-4.
Yep.
Sorry.
Not you. People behind me. Okay, so we are doing the list of all rational roots with P over Q. And again, you make sure you divide all the P's by all the Q's, find that entire list. We talked about Descartes' rule of signs, which can tell you how many positive and negative roots you have. And then you use those with synthetic and rational root theorem that we talked about last week to find those answers. So what we're going to do is we're going to do one more example where we go through all of those steps again, just to make sure you understand how to do that, since you've had a weekend to kind of buffer in between. After we finish that, you are going to have the rest of the class to work on your homework over 4, which I haven't given you yet. You're going to get it here today. So, because this is all we have. So, all right. So, we're going to all right, so here's the problem. So we're going to list all possible roots, use Descartes' rule of signs to determine positive, negative, and complex roots of f of x equals 2x cubed plus 3x squared minus 8x plus 3 equals 0. Then we're going to use those and find the possible roots. All right. What is my P?
Your P is
What is my Q? So, have to list all the factors of P, all the factors of Q. Well, P is just plus or minus 1, plus or minus 3, right? 2, plus or minus 1, plus or minus 2. So now, we want to list all possible factors. So all the possible factors are plus or minus 1, 1 divided by 1, plus or minus 3, 3 divided by 1, plus or minus 1/2, 1 divided by 2, and plus or minus 3/2, 3 divided by 2. Again, every P has to divide by every Q. Does it make sense how I found those factors? Okay. So there's step 1. Now we got to use Descartes to find the positive, negative complex. And then after that, we got to actually find the roots, doing synthetic. So Descartes all looks at sign changes of f of x and then f of negative x to tell us how many positive, negative, and complex roots we can possibly have. So if we look at f of x, 2 to positive 3, is that a sign change? No. 3 to negative 8,
Yes.
there's 1, 2. So by Descartes, that tells us positive rational solutions, there's either 2 or 0. Because again, it's minus 2 for each one. So that's the first part. Now we got to do f of negative x. So everywhere there's an x, we have to make it negative. And what did we say Friday? What's the shortcut for these?
Make it all positive.
Only change the odd powers, right? So that makes that negative 2x cubed plus 3x squared minus, or plus, sorry, 8x plus 3. So there's only one sign change in f of negative x. So that tells us negative rational roots, there's 1. So how many total roots are there? 3, because our degree is 3. So we know I either have 2 rational roots, positive rationals, and 1 negative, or I have 0 positive rationals and 1 negative, which then means the last 2 are complex. So that tells me for complex, I either have 0 or 2. I have 0 if I have 2 positive. I have 2 if there are no positive roots. Everybody with me there?
Yeah.
Okay.
There's got to be 3 total, right?
3 total. So for this, which one is guaranteed? The negative. So to me, the most rational spot to start is finding that negative. Because if I know I have to have at least one that's negative, well, I only have to test 4 numbers. Whereas if I'm trying to find a positive, well, then I got to test 4 numbers, and then I could find out, oh, well, it's none of those. So then if it's none of them, then I have to test all 4 negatives anyway. So why not start with the one I know is guaranteed? All right? So what do we want? What's the most logical spot to start? Negative 1. So let's put negative 1 in the box. And we're doing synthetic now. And what are my coefficients? 2, 3, negative 8, positive 3. And again, if you prefer to do long division, that's fine. You would divide by x plus 1. 2 comes down. 2 times negative 1 is negative 2. And add. 1 times negative 1 is negative 1. And add. Yeah, negative 1 doesn't work. I get 12. What's my next option? But again, I only want to do negatives right now. So negative 3 is my next one. So I'm going to change this now to negative 3. Bring the 2 down. 2 times negative 3 is negative 6. And add is negative 3. Negative 3 times negative 3 is 9. And add is 1. And I get a remainder is 0. So what's that tell me? My negative root is negative 3. So x equals negative 3 is one of my roots. How big is the depressed polynomial on left? What's the power of it? 2. So it's a quadratic, right? So constant x squared. So I've got 2x squared minus 3x plus 1 equals 0. So now that I have that, I can either do quadratic or I can factor using AC method. We haven't done AC in a while, so why don't we try that, see if that works. 2 times 1 is 2. I need two numbers that multiply to 2 and add to -3. Is that possible? -1 and -2. Very good. Now I replace the middle term. 2x squared minus 2x minus 1x plus 1. Now what do I do?
Greatest common factor.
Greatest common factor. Split it. What do the first two have in common? 2x. Now, I switched the order there. Do you have to do that?
No.
No, I just prefer, if I can pull the same number out, I prefer to do that. So I get x minus 1. How about the second two? -1, which gives me x minus 1. Do my insides match? Yep. So I get 2x minus 1. Outsides go together. Copy an inside. So I got 2x minus 1 and x minus 1. Now what do I do with both those factors to solve them? Put them equal to 0. 2x minus 1 equals 0. So I solve that. I get x equals positive half. This one, x minus 1 equals 0. I get x equals 1. 1, 2, 3. So, in that case, we ended up with 2 positive reals and 1 negative. Now, do you now see why Descartes' rule of signs is helpful? Does that help to make sense? Because otherwise, we would have had to have just started going through them, and we would have gotten lucky and saw, okay, well, 1 works right away. But what if there was no real positive real? We would have tested 4 numbers for nothing. So that's where you always want to find, okay, where's the most logical place to start? Well, if you end up with either 1 positive or 1 negative, that's usually where I start, because then I know, okay, I only have to find 1. And then I can work from there. Any questions on that? Like I said, the example we did in class on Friday was harder on purpose because I wanted you to see how it worked on a bigger power. Most of them you're going to be working with our degree 3 cubics. Questions? You feel okay with this? All right. So I'll give you the homework here and give you the rest of class to work. Not too much, please. Now I might be a little late for practice. All right. So 10 through 22 evens is your homework for 4-4. Tomorrow in class, you're going to be doing, this is purely a formative assessment, but you're actually going to turn this in and let me look at it and see how much we remember of 1, 2, 3, and 4 on concepts on top of what we've taken in the quiz. So that we have 2 data points. So it's going to be an ungraded thing, but it will go into the grade book in that non-graded category. So this is the 4-4 homework. You will get back your other quizzes tomorrow, as well as the assignments. So we'll take a look at your quizzes tomorrow so you see where you're sitting. With lots of people gone at DECA today, that's just kind of where we're at. So that's the plan for tomorrow. Wednesday you don't have school, so then Thursday we'll start 4-5. Yeah, right. Yeah, that's fine.